Hello, today we start complex analysis. First of all, uh, if we talk about the equation like this, x square plus 1 equals 0. Did it have any real solution? No, it does not have real solution. Because we know that it will come x square equals minus 1, so this implies that x equals square root of minus 1. And there is no real number exists like that. Then the concept of square root of minus 1, it's meaningless in real number system. So for this, there is a mathematician whose name is Euler in 17072, 1783. Was the first mathematician who introduced the symbol iota with the property I square equals minus 1. Means the square root of minus 1 is I. We call it iota. Okay. Now how can we write the complex number? A complex number is written as z equals x plus iy, where z is called complex variable. X is the real part and y represent the imaginary part. Okay. If x is 0, then it means z equals iota y. Then z is called purely imaginary. The complex conjugate. If we have a complex number x plus iy, then complex conjugate is denoted by z bar, and this will be equal x minus iy. Means you have to replace I with minus I to find the conjugate of any complex number. Is it clear? Okay. So we move to next. For example, if we have a complex number like that, minus 3 minus 5i. Okay. then its complex conjugate will be minus 3 plus 5i. This is the complex conjugate. If we add, we know z is x plus iy, and z bar means complex conjugate of z is x minus iy. If we add both these, then what we get? Z plus z bar equals 2x. Means the real part in the form of, in the terms of complex and complex conjugate, it's written as z plus z bar by 2. And we can represent x as real part of z. And this is equal z plus z bar by 2. Likewise, if we subset these two, then what we get? Z minus Z bar equals 2iy. So the value of y will be Z minus Z bar upon 2i. It means y is the imaginary part of Z. So we can write imaginary part of Z equals Z minus Z bar by 2i. So this is the imaginary. So is it clear? If complex and complex conjugate are given, then we can easily find its real part and imaginary. Now the next is equality of two complex numbers. Equality of two complex numbers. If we have given two complex numbers, z1 equals x1 plus iota y1, likewise z2 equals x2 plus iota y2. So z1 will be equal to z2 if and only if ये तभी इक्वल होगा if यदि रियल पार्ट रियल के बराबर हो और इमेजिनरी पार्ट इमेजिनरी पार्ट के means if we talk about complex system या complex for complex number, the comparison is not done. We can't say any now which complex number is greater or which complex number is lesser. Okay, means greater than or less than have no meaning in the set of complex number. Greater than or less than have no meaning. In the set of complex number. Now, operations on complex number. Fundamental operation on complex numbers. First one, addition. Means if we have given two complex number, then how can we? So first operation is addition. One number is a plus ib, second number is c plus id. Then it will. Then how we can add? Just add real part with real part and imaginary part with imaginary. So we get A plus C plus I B plus D. This is the answer. So it is very easy to add any two complex number. Likewise, subtraction. If we have two complex number A plus IB minus C plus ID, just subtract real part with real part and imaginary part with imaginary. So this is the subtraction rule. Third one is multiplication. A plus iota B, C plus iota A. So just multiply real part with real and imaginary part with imaginary. And you know I square is minus 1, so real part will be AC minus BD. And imaginary part will be A with imaginary part, beside B with real part. So what we get? BC plus AD. The fourth one, division. A plus IB upon C plus ID. जस्ट अप्लाई कंपेंडो एंड डिवाइडेंडो रूल हियर, जिसको हिंदी में हम हाइपरमेग्रन कहते हैं। तो इसको हम लगा सकते हैं C minus ID and C plus ID. Sorry. If this is positive sign, then these both will be negative. So it will come AC plus BD I BC minus AD upon C square plus D square. So it will come AC plus BD upon C square plus D square plus iota BC minus AD upon C square plus D square. So these are the rules to add, subtract, multiplication and divide of any complex numbers. Now how we find the absolute value of any complex number. Absolute value. The absolute value or modulus of a complex number Z equals A plus IB is denoted by modulus of A plus IB and is defined by modulus of A plus IB equal square root of a square plus b square. So it means the modulus of z will be square root of a square plus b square. Yeah, we can write modulus of z square will be a square plus b square. Okay, so we can write it z square means a, it is a plus ib, a minus ib. This one is a square plus b square means we can write like that. A plus ib into a minus ib. And we know this is z and this is z bar. So it means modulus of z square is equal to z bar. Also we know one more thing. Z1, Z2 bar will be Z1 bar, Z2. Now we move to next. Geometrical representation of complex number. So we have axis like that. This is X, X dash, this is origin, this is Y dash. Okay. So if we have a complex number z equals x plus iy, we can also represent it like that ordered pair xy. Okay. In the complex number, they are correspond one and only one point in the xy plane. Means if this is x, if this distance is x, this is y, so this will represent this point. This is p. This represents a point. And here the plane is known as Argand plane. The plane is called Argand plane or Gaussian plane. The representation of complex number is called Argand diagram. The representation of complex number. Diagram. Now if we want to find the distance between two complex planes, so the distance between two complex now. If we have a number z1 equal to x1 plus iy1 and z2 equal to x2 plus iy2. Then modulus of z1 minus z2 will be square root of. This is the distance between z1 and z2. So it is x1 minus x2 whole square plus y1 minus y2 whole square. Now polar form of a complex number means how we can represent a complex number in polar. So if we have a complex number z equals x plus I. Suppose we represent this number on plane. So this will be like a point. So this is suppose this is a point P and its coordinate is x comma y. So here the value of x is r cos theta and value of y is r sin theta. We all know these are the polar coordinates. So if we add these, if we square and add these, then what we get? X square equals r square cos square theta, and likewise y square equals r square sin square theta. If we add these, then what we get? X square plus y square equals r square cos square theta plus r square sin square theta. So x square plus y square will be r square. So from here we can find r equals square root of x square plus y square. If we divide these two, and we get tan theta equals y by x. So this implies theta will be tan inverse y upon x. Okay. So it means z, it follows that z equals x plus iy, and it is written as r cos theta plus I sin theta. Also, it is written as r e to the power I theta. And it is called a polar form of a complex number. It is called polar form of a complex number, where r and theta are called polar coordinate of z. R is called modulus or absolute value of z. The angle theta is called argument or amplitude. So theta is called argument, oblique amplitude. So it means theta is amplitude of z. It can be written as like that. or it can be written as like argument of Z. Argument of Z is not always unique. Since there is one more thing, principal value of the amplitude. If theta is lies between minus pi to plus pi, then this is known as principal value argument. Okay, thank you.